This is my video presentation about assessment 3. My assessment 3 submission involved, the name is Proposed Problem Solution Based on Data Analysis Using Statistical Programming for a Baloney Data Set. So this involved with an introduction. Introduction include where I get the data from. Actually, it's from UCI Machine Learning Repository, and then brief discussion about the history of the data. And then after that, I have a description about the data set description and objectives. So I mentioned about data set, a little bit of detailed description, and then problem. Actually, it's objective is predicting a Baloney age from physical measurement. The solution, the steps we are going to do, I'm going to do is step 1, we do data analysis. 2, outcome of the data analysis. 3, data pre-processing. Step 4, model building and model interpretation and validation. For the solution part, we do the data analysis for the proposed data set, exploratory data analysis, distributed statistics. We do these sort of things, and then we can from these statistics we can find out that there is 4,177 observation and 9 variables. There is 1 variable, rings, is a response variable, while the remaining 8 variables are potential predictor variables. So the data shall be visualized with box plot, stacker plot, scatter plot, histogram plot, etc. So from there we can see, for example, here got some outliers we can see, and then also here got a few outliers we can see. Okay, and then we carried out what is it, correlation matrix. From there we can see the correlation coefficient. So in conclusion of that, from the EDA we found out that there is a significant relationship for the 7 continuous variables, and also it has a relationship with the categorical variables. Then after that we check it out, a summary of the model result, and then each and every variables, and found out that all has a significant relationship. But when we check it out with the multiple linear regression model, it is observed that the sex and then the length are not significantly related based on the p-values. Then from there I summarize out the outcome, what I have found out, and then from there, based on these observations, we proceed with the data pre-processing and data modeling. For data pre-processing, we clean up the data, whatever, if there is a not valid data, outliers, we clean it up. Then after that we have a good data set. So with this data set, we will do the model, construct the models. Based on here, I carried out with backward elimination, stepwise regression, and forward selection methods. All 3 methods come out that 6 variable selection is the best, something like that. So, but actually it is all 3 methods come out with exactly the same result. Hence, I continue with the best subset selection method. Then from there also we found out that the number 6 variables is the best subset selection based on, let's say, the adjusted R-square, 6 variables, minimum CP for minimum BC. These are 6 variables. So from here we found out that 6 variables are the best subset selection. And then we carried out a model interpretation by K4 cross validation technique, and then from there we can get a formula. Here this is a formula, the rings that which are the 6 variables. So this is the formulas, and then we come out, check it out, the minimum CV errors, and then from this minimum CV errors is one of the number 6 variables. 6 variables, confirm that 6 variables give the minimum cross validation errors. So it is conclude that, and then based on these values we have a coefficient. These coefficients, so we put it in the equation form. This is find the best fit model for abalone age prediction. Here is the equation. So this is it for my video presentation. Thank you very much.